Okay, in this video, I will solve the first question from a practice questions for the final. So this is the one I will be solving. Let's see. So it's a question about reserve price in the second price auction. We have two bidders. So I'll just write two bidders and their values for each bidder. So for V1 and for V2 are coming from set of three values. So your value can be 0, can be 1, can be 2, and the same true for second bidder. And all values are equally likely. So probability that your value is 0, for example, is 1/3, right? Yes. Okay, it's a second price auction with a reserve price. So auctioneer will introduce a reserve price. The reserve price is publicly known, so there is nothing tricky about it. Bidders know the reserve price, so the meaning of reserve price is that you have to bid at least reserve price in order to win the object. And if you win, you will have to pay at least reserve price. So kind of a good way of thinking about how to do this in this auction is imagine there is a third bidder, which is seller himself, who would introduce a bid of R into the auction and then just apply the standard rules of the second price auction. This will do the trick. Okay, so in part A, simply asks us for any reserve price, how bidders would bid, and the presence of reserve price in the second price auction doesn't affect the behavior of bidders. The reason is I just kind of told you how to implement the reserve price. The reserve price is just effectively as can be viewed as a publicly known bid from some other player, and this publicly knows that the fact that somebody will be bidding the reserve price doesn't actually affect your strategy, especially if you're trying to win the object. Now, of course, you know that by bidding below reserve price, you will guarantee to lose, so you will be guaranteeing you will guarantee to get 0. In that sense, of course, you don't have to bid your value, but you might as well bid your value because you will simply just lose the auction. So we will assume that bidders will bid their values. Bidders bid values. And now for the rest, for parts B, C, and D, we will be simply calculating auction revenue depending on the reserve price. So the best way kind of to solve this question is just to create a table. So bidders bid their value, so their bidding function is B1 will be bidding his value V1, and B2 will be bidding his value V2. And for V1 and V2, we know their distributions. They come from, they are random variables that take three values, and equally, all outcomes are equally likely. So the table will be, so effectively we can have bid of player 1, bid of player 2, and we have three values, so we'll have 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, and finally 2, 0, 2, 1, 2, 2. Overall, we have to have 9 outcomes, and their respective probability will be just the product of two probabilities. The probability is that simultaneously bidders 1 value is 0 and bidders 2 value is 0 is 1/3 times 1/3, which is 1/9. And kind of this is another way to make sure that you did all of this correctly, is that your probabilities will have to sum up to 1. So here we'll have probability 1/9 everywhere. So for each outcome, they're all equally likely. Now, of course, if distribution was somehow different, that would be different. Okay, and now we calculate revenues. In part B, it will be when reserve price is 0, reserve price of 1 for part C, and reserve price of 2 for last part D. So I'll just do all parts at once. One by one, but in one table. All right, so when there's no reserve price, then when both bidders bid 0 and 0, one of them will win because one of them will be the highest bidder. The second highest bid is 0, so the revenue of the auctioneer, of course, is 0 in this case. And of course, it will be, but for example, in second case, bidder 2 will win because he's bidding 1, bidder 1 bids 0, therefore bidder 2 wins and pays 0 because it's second price auction. So 0, 0 here, now 0 here for the same reason. Now 1, 1, again we have a tie, but now price will be 1 because the second highest bid is 1. 1, 2, bidder 2 will win, pay 1. 2, 0 is 0 again, 2, 1 is 1, and finally 2, 2 is 2. Okay, therefore for part B, our expected revenue will be how much? So all outcomes are equally likely, so therefore we can simply calculate, take a sum of these values and divide it by 9. So it's 1 plus 1 plus 1 plus 2, that's 5. 5 divided by 9. So that must be the revenue. Okay. Now notice that if it wasn't the same probabilities, then you have to kind of carefully multiply. So you take this value multiply by this probability, this value by this probability, and so on, and then sum this together, a regular calculation for expected value of a random variable. Now let's do next part, reserve price of 1. So then in the first case, when both bidders bid 0, they're both below reserve price. Seller gets nothing, but he keeps the item. Now when it's 0, 1, now bidder 2 will win, but he will have to pay 1 because he's bidding above 1, and the second highest bid is essentially 1. So we can always think about this as a third bid, which is always 1. So you will get 1 here. For the same reason, you'll get 1 here. Now 1, 0, he will get 1 here. 1, 1, he will get 1 here. 1, 2, he will get 1 here. 2, 0, so here reserve price will also help. 2, 1 will get 1, doesn't change, and 2, 2, he will still get 2, because in this case reserve price doesn't affect that outcome. Right, so we can see that Actioneer clearly benefited from reserve price, because for all 9 cases he's doing weekly better. 0, 1, 1, 1, 1, 1, 1, 1, 1. So there are a couple of cases where reserve price actually saved the day. For example, this, because when bidder 1 was bidding 2 and bidder 2 was bidding 0, bidder 1 was winning and paying 0, but now with a reserve price of 1, he will be paying 1. The same occurred in this case or in this case. So we see that this must raise revenue for the Actioneer. Okay, again, we can simply just sum it over and divide by 9. 1, 1, so 3, 4, 5, 6, 7, plus 2, that's 9. 9 over 9, that's 1. All right, and finally, reserve price of 2 for part D. So same calculation, but now we have to again go through each case and figure out what happened. So first case now have to be 0. You cannot do better. Notice now that you also will get 0 here, because if reserve price is 2, none of the bidders will win. Now this case it will save, because now this guy will actually pay 2. Then 0, 0, 2. And finally 2 for the last for 3 other cases. All right. And so now we have 1, 2, 3, 4, 5. 5 times 2 is 10. So we have revenue of 10 over 9. So that's how we get these numbers. So just be careful. I think the only caveat here is the way I calculated these numbers very quickly by summing numbers. That only works when probabilities are the same. Otherwise, you actually would have to kind of, but I mean, there's problem set questions like that, so you should be fine. Okay, so let's finish this video. That's how you solve question 1.